Okay, this talk is going to be about the current Year 12 chemistry assessment task and how I would go about answering the questions and writing the questions. What's on the screen you can see right now is what I think the most tricky part of the assessment and also the most important to get right. This is like the criteria which tells you what sort of questions you've got to write for each focus area. Now, having no more than 25 marks is fairly easy. You just got to make sure you haven't got the right amount of marks, but it's these ones I've flagged with arrows at the side which are going to make the difference to the assessment. And the first one is the fact that you need at least one big mark question, one medium mark question, and one low mark question. This point here is fairly straightforward. It just means that you need to have at least one question with more than 4 marks that's not a multi-part question, so it hasn't got A, B, and C, it's just a standalone question. That's not too complicated. The next complicated thing is the fact that you need to have a range of different verbs in your questions. Making sure the verbs aren't used more than twice is just easy. It's just a bit of housekeeping. That shouldn't be too hard to do. This is quite a challenging one, the skill-based questions. You need to have one question for each focus area based on a skill or a stimulus, and we're going to go into that detail today. And the last one, something we haven't talked about very much, is the fact that in each focus area, one question must be related to either applications of chemistry, one question has to be related to impacts of chemistry on society or the environment, and one question has to be about current research. So we're going to go and look at today where we could fit those questions in to the focus areas. The first thing I want to talk about is with the verbs. You've got to write one question 6 to 8 marks, one question 4 to 5 marks, and one question 2 to 3 marks. And you've got to have a question from each of the verb levels, and they pretty much go together, and you can make your life a lot easier if you follow the table which was given to you in the assessment notice. And there are some verbs that go with 1 to 3 mark questions. There are some verbs that go with 3 to 6 mark questions, and there are some verbs that go to 5 to 8 mark questions. So if you're sensible when you're designing your questions, you'll make sure that you use the right verb with the right questions, and you'll actually be achieving both these outcomes at the same time. So when you assign your 6 to 8 mark question, make sure it's got a level 3 verb. When you assign your 4 to 5 mark question, make sure it's got a level 2 verb. And when you assign your 2 to 3 mark question, make sure it's got a level 1 verb. And if you've done that, that means you've achieved both those requirements for the task. The skill and stimulus is a challenging bit. You need to have at least one of each of these sort of questions somewhere in your whole set of questions, and 2 of these sort of questions somewhere in your whole set of questions. And if you look at it, you'll see that there's 6 different sorts of skill or stimulus questions you need, and there's actually 6 focus areas you've got to write questions for. So as a hint I'm going to give you, choose one of these skills or stimulus for each of the focus areas. Only question you've got to ask yourself is which skill goes with each focus area. With these 2 down the bottom, the mathematical questions and the compulsory experiment questions, you've only got to do 4, which means you don't have to do them for all the focus areas. So the thing you've got to ask yourself is which focus areas are they best suited to? And also, is it, for all these questions, is it possible to combine them with the skills and stimulus above? So for example, you could do a question about a compulsory experiment that involved a diagram, or involved a table, or involved a graph. And by doing that, you're actually covering 2 of the requirements at the same time, and that's perfectly allowed in this assessment task. So what I'm going to skip forward to is start looking at the syllabus. This is the first focus area we have to do, and in class previously we've actually broken it down into chunks of the key ideas, because part of this assessment task you're actually trying to demonstrate that you understand the key ideas of the chemistry syllabus, and the way to do that is to make sure you've asked a question on all the key ideas. So by breaking down the page of the syllabus into what the key ideas are, and you try and ask a question on each one, that means you're demonstrating you understand the chemistry. And in this particular page we've done in the past, the first part was about writing balanced chemical equations and formulae. The second part was looking at how we actually get ethylene from fossil fuels. The third part was about the reactions of ethylene and all the many products that ethylene can be turned into. Then we had a focus on polyethylene and polymerization and how polymers are made. And lastly, we looked at some of the applications and uses of a range of different polymers. So if I was writing questions for this particular page of the syllabus, of course I'd follow the requirements of the assessment, make sure there's a skill question, make sure there's a stimulus question, etc. But I'd try and make sure I had 5 questions or 6 questions to make sure I covered each of those different parts. And that should obviously be number 5. So that's something you can do, and I'm happy to help you with that if you need to. If you want to send me what you think the important ideas are, I'm happy to go through that with you. But today we're going to focus on ozone. And the first thing we're going to do is actually break down the ozone page into what are the key ideas in the ozone page. If we look at the instruction, the heading, it's all about the fact that human activity has caused changes in the composition and structure of the atmosphere, and the fact that chemists monitor these changes. There's two key ideas here: the structure of the atmosphere and the monitoring of the atmosphere. And we want to do that so we limit damage. And if we start looking through the syllabus, we'll see that the first 3 points in the second column are all about the structure of the atmosphere. So if we look here, we've got structure of the atmosphere, we've got pollutants in the atmosphere, and we've got the role of ozone in the atmosphere. So these first 3 points are all about the chemicals found in the atmosphere. So this is the first big idea in the ozone topic. What is the structure of the atmosphere and what chemicals are there, what pollutants are there, and also the fact that ozone is actually a chemical that's actually useful in the atmosphere but also a pollutant at the same time. So that's the first big idea in this page of the syllabus. And that also links into this idea of structure in this first column. The next big idea as we go down is we learn something new in the chemistry course. It's all about something called coordinate covalent bonds. And because that's the first time that's been encountered in the chemistry course, that's an important idea that stands on its own. So what is a coordinate covalent bond, and can we draw Lewis dot diagram structures of coordinate covalent bonds? Then we actually apply that to looking at oxygen and ozone and oxygen free radicals. Once again, free radicals being something fairly new for the HSC course. So can we use our new understanding of coordinate covalent bonding to describe the properties of ozone, oxygen and oxygen free radicals? The next few bits are now we're starting to focus on one particular pollutant in the atmosphere, and that's CFCs. And so we look at where CFCs come from and halons come from, what are they? And we also look at how they damage the atmosphere. So those two sections go together. So what are CFCs, where do they come from, why they were used, and how do they damage the ozone layer? Then we look in general at what haloalkanes are, because CFCs are an example of a haloalkane. We look at what is a haloalkane, and we learn all about modelling and naming haloalkanes. That's another section of the syllabus. We also have, well, CFCs are so bad, what are we going to do about them? So how can we actually fix the problems caused by CFCs? So we look at some of the replacement chemicals, we look at how ozone is monitored, and we also evaluate the effectiveness of those strategies used to replace and fix the problems caused by CFCs. One more thing you might want to do, and this is not necessarily true because there's many ways of chunking up the syllabus, you might also link this last point here on monitoring with the first column, because the first column is all about how we monitor the atmosphere. Obviously this topic is chemical monitoring and management, so monitoring is quite important. So there's a range of different big ideas here. We've got the atmosphere being 1, coordinate covalent bonding being 2, we've got properties of oxygen 3, we've got CFCs being 4, we've got haloalkanes being 5, we've got CFC replacements being 6, and we could even have monitoring being 7. So there's 7 different big ideas in this page of the syllabus, which is a bit of a problem because one of the rules for our assessment task, if we skip back to the beginning, is that we can only have 25 marks. And considering that one of the questions is going to be 6 to 8 marks and one of them 4 to 5 marks, that means we haven't got that many questions to play with. So we need to start being a bit clever with how we design our questions. And something we can start doing, we can even start thinking about combining some of these points together. We might ask a question that covers 2 or 3 of these ideas at the same time. Probably a high mark question if it's going to be covering a whole range of ideas. So where do we go from here? We've got these 7 big ideas. What do we need to do? And what I'm going to suggest is probably the trickiest part of the assessment is actually matching up the skills. So what I would do now is I'd come back to here and think which skills or which stimuli go best with that page of the syllabus. A graph stimulus, that's possible. You could show a graph of changing ozone levels in the atmosphere, or changing chlorine levels in the atmosphere, or changing uses of CFCs, HCFCs and HFCs. That's something you could do, a stimulus. It's possible to use a quote or a paragraph. You could have a paragraph or a quote about environmental monitoring, about the impacts of ozone, and get students to write a paragraph about that. A table stimulus, that would be possible too. You can make a table of properties of CFCs, HCFCs and HFCs and get students to explain. A diagram stimulus, some possible ideas could be diagrams of the ozone layer taken by satellite measurements and asking students to explain how the measurements were taken or to explain why there's a hole in the ozone layer. Drawing diagrams, that's something that's possible. Possibly with drawing haloalkanes, could something be done? We could ask them to draw a picture of a haloalkane or even an oxygen molecule or an ozone molecule. Drawing a graph, that's one that I probably wouldn't consider for this one because we didn't do any graphing skills in this topic. It's not something that necessarily goes with this topic. You could do it definitely, but it's not something I'd think about. Mathematical calculations, you could incorporate some sort of moles calculation with ozone, but that's not a big focus for this focus area, so I wouldn't worry about that either. And compulsory experiments, we did do a modelling haloalkane experiment, but it's not one of the most important experiments as far as first-hand investigations goes, so I might skip that as well for this particular page. So I've got a choice of 5 things, and I'm going to choose one today because you need to make a start somewhere, and once you've chosen one, it just means you take that one off the list and you need to make sure you use the other ones in your other questions. So what I'm going to do is I'm going to start off with a diagram stimulus. That's what I'm going to do today for my first question. And my first example question will be using a diagram stimulus. So I'm going to call it question W. And what I would do for this question was I would give students a diagram stimulus, and that diagram will be pictures of 3 different haloalkanes. So I've got haloalkane number 1, a picture of it there. I'd have haloalkane 2, a picture of it there. I'd have haloalkane number 3 and a picture of that there. But I'd make sure that one of these was a CFC, one of these was the HCFC, and one of these would be a HFC. And I'd be, what part of the syllabus are we looking at? I'd obviously be looking at this section. This would be my question W. W part A is learning all about haloalkanes. So I've got these 3 pictures. This one will be a CFC, this one will be a HCFC, and this one will be a HFC. And just as an example, this one might be a picture like this. Okay, I'll leave you to decide what those ones could look like. And the question might be something like this. The question might even be set up as a table. And the question might just be, question W part A, complete the table. To identify, and there's our verb, complete the table to identify the type of chemical and its systematic name. And I would have, probably label these as number 1, 2, and 3, so I'd have down the side number 1, number 2, number 3, and I'd have space for them to fill in the details. And to give the students a better idea of what the question is actually asking them, I might have type and name, and I might give them that number 1 would be a CFC, and that number 1 would be chloro, trifluoromethane. I give them that type and name to give them a clue of how to answer the question, and they'd have to go through and do 2 and 3 themselves. And I might assign that to be, say, worth 2 marks and give 1 mark per row or 1 mark per column. That's a small mark question. I've got an identifier, so I've started covering the syllabus, or started covering the assessment requirements. But I want to make that question a bit bigger. I'm going to put a part B in there as well. So W part B, I want to include some more verbs. W part B might be a bit more complicated, requiring the students to do a bit more work. And I'm going to choose a higher level verb and give it some higher marks. So I might have something like justify. Justify the changes in use of these chemicals. Over the last 30 years. And I might assign that to be, say, a 6-mark question, so that's 8 marks in total. This question, justify the use of the change of these chemicals, actually is quite a complicated question, because to justify the changing use, they've got to say why CFCs are being used less, and they've got to say why HFCs are being used more now, but why HCFCs were used in the middle. So it actually covers a little bit of part 4, so why were CFCs used and what are the problems with CFCs, but it also covers part 6, which is why the replacements are being used and also evaluating the effectiveness of those replacements. So that would be W part B. So in that question W, I've covered 3 of those 7 key ideas from the assessment. And if we look, we can start filling in this little guideline table that you've been provided with as well. So the first question for 9.4.4 was question W. Question W was a 6 to 8 mark question. It wasn't a whole question though, it had parts. It did include a level 1 verb. WA had identify, and it had a level 3 verb as well, because W part B had a justify. Was it a skill and stimulus question? Yes, it was. W part A required them to use a diagram. Did it involve H3, 4 or 5? Quite possibly it did. H3, 4 and 5. Let's go back and refresh what those were about. Oops. Oh, my goodness. Exciting video just there. Okay, H3, 4 and 5. Applications of chemistry, impacts of chemistry on society and the environment, or current research in chemistry. You could argue that it was to do with applications of chemistry because they use CFCs for a particular reason. I would say that it's more likely to be a H4 question. We're looking at the impacts of CFCs on the environment because you need to justify why they stopped using CFCs, which means you'll need to have somewhere in your answer the problems that CFCs caused for the environment. So we can actually say now that W part B was involving with H4, skill H4. And so we can start filling in this table. What's some other questions we could use? Let's have a look. What other questions can we do? Let's go back to our syllabus. I've got an extra page in here which I probably should have talked about earlier, is that this was a question from the 2012 HSC paper. Obviously we can't use it in our assessment tasks, we can't use HSC questions, but it was say to draw a label diagram showing the layered structure of the atmosphere, and in your diagram name 2 atmospheric pollutants, position the layers where the detrimental impact occurs, and the sources of the pollutants. So this question from the HSC was actually covering this section here, was describing the structure of atmosphere, because they had to draw a picture, and also what are the pollutants in the atmosphere. So that's an example of how one question in the HSC can cover 2 different dot points. For our assessment, that would have been considering the one big idea, but that's an example of a question that has been asked on CFCs in the past. So what's another question I could ask? I've got a skill question out of the way. What's some more questions we can ask to cover some more points? Another idea. Another big mark question. Call this question X. I'm going to make it a 6-mark question. Assess, another high level verb. Assess the impacts of atmospheric ozone on the environment. And once again, this question is designed to cover a couple of big ideas. Okay, this is covering the idea that ozone in the upper atmosphere is good because it acts as a UV shield, but also lower atmosphere as a pollutant. So students answering this question will need to say the good points and bad points, hence the use of the word assess. And so that means we can put question X into our high-level verb question. It's also a 6-mark question, so it's a whole mark question bigger than 4. So we're covering some of these key ideas from this assessment task. What's some more questions we could write for this part of the syllabus? We've got W, we've got X. For Y, we need a small mark question. So for Y, we could ask the students to present. Present label diagrams of ozone and oxygen to compare their intra and intermolecular bonding. And I'll give that, say, a 3-mark question. So we're using a verb present. We've got the verb assess there as well. It's a 3-mark question. It requires the students to actually draw diagrams. So technically, I've covered another skill, which if we take the time to scroll back and find that skill, we've got a diagram stimulus. They're requiring the students to draw a diagram too. However, I need to do one of these for each focus area. So this wasn't necessary. I thought it was just a useful way of asking this question. But what does this cover? This actually covers 2 parts because the students have got to talk about the inter and intramolecular bonding, which is related to both these sections. This is our question WX. This is our question Y. And once again, we've got a low-level verb. So if we went back to our page, we've got a verbal 1, Y covers verbal 1, and now we've got a 3-mark standalone question as well. So we're almost done here. We're getting a lot of marks. We've got an 8-mark question and a 6-mark question, makes 14. We've got 3 more marks, which makes 17 marks. But we need 1 more 4 to 5 mark questions. We need to think of 1 more question we could ask that's around 4 to 5 marks that's got a verb level 2. So what questions could we possibly ask? Well, let's see what we haven't asked questions about yet. Are there any big ideas we haven't asked questions about? We've asked a question about 1, that's done, 2 is done, 3 is done, 4 is done, 5 is done, 6 is done. Only thing we haven't asked a question about yet is this section 7 down here about monitoring the ozone layer. So we could ask one last question on that. So question Z, we need a 4 or 5 mark question with a second level verb, so we could use a describe. Describe the methods used to monitor the ozone layer. And I could assign that 5 marks. You could even assign it 4 marks if you wish, depending on how many marks you had spare in the whole paper. You've only got 120 marks for all the questions, so depending on how many marks you're up to, you could make it a 5 mark question or a 4 mark question. And so that's the way I would break down this assessment task. Just refreshing, the first thing I would do is I would break up the page of the syllabus, so what are the key ideas I wanted to ask questions about. I would then go back to the skills and think to myself, which skills go best with this particular page of the syllabus, and I'll make sure I write a question for that first to get that out of the way. I would then think about which of these outcomes goes best with this page of the syllabus, because you have to do one of these for each one. And once I've got those two things out of the way, it's a simple matter of just writing some extra questions to use the right number of verbs and also the right number of marks for questions. And that's it. If you've got any questions, you can happily ask me or email me. And if you need some help chunking up the syllabus and breaking it down, I'm happy to help with that as well. There might be some questions in just a minute. This is just some questions that have been asked for me during this session, so I thought I'd answer them now on the video. The first one was, can we use graphs or stimulus that we find on the internet? And the answer to that is yes. If you're doing, say, a stimulus on the ozone layer, you're more than welcome to go on the internet and find some graphs about how chlorine concentrations have changed or ozone hole size has changed over the last so many years and use that as a stimulus. So yes, that is a definite yes for that one. Can we use these questions? Yes. As a head start to your assessment task, if you wish, you may use the questions we talked about in this presentation today. It'd be nice if you could make your own questions or some of your own questions, but you'll not be penalised for using these questions because this is supposed to give you a stimulus or a head start for your assessment task. Can you use any questions from the ozone booklet or from stimuluses or resources that were linked to from the ozone booklet? And the answer to that is yes as well. As long as they aren't past HSC questions exactly, you're allowed to use them. Do we have to use all the verbs? The answer to that is no. You just need to make sure that you use each level per focus area. And if I just double check the instructions, I'm pretty sure that you can't use the same verb more than twice in the same focus area. Just doing a double check. I'm getting confirmation of yes from the audience. Yes, so for in each focus area, but in that focus area, same verb, not more than twice. And the last question, do we have to cover every dot point? And the answer to that is no. How the marking works, the marks you're getting for covering each page of the syllabus is marked on how thoroughly you have covered that page of the syllabus. And for example, in the questions I wrote here, I didn't cover every single dot point. I just tried to make sure I had a spread across all the main ideas. It would be perfectly possible, I suppose, to write all your 25 marks worth of questions from this one dot point, and you might write fantastic questions and fantastic answers and get all your marks for the design of your questions. But when it comes to me marking how well you've covered this page of the syllabus, you're not going to get a very good mark because you haven't shown any knowledge of anything else except this one dot point. So no, you don't have to ask questions on every dot point. You don't necessarily need to ask questions on every section you've chunked out as well. I'm recommending you should, but not every dot point. Just do you have questions that covers the broad ideas of this page of the syllabus. The question was, what sort of compulsory experiment questions can you do? There's a whole range of questions you can ask. You could ask them what was the method they used. You could ask them how they made sure their method was valid or reliable. You could ask them what you'd expect them to observe if they did something. So if a student poured bromine water into cyclohexene, what would they observe? You could ask them to write the chemical reactions that take place or chemical equations that take place. If you had a question on, say, fermentation or molar heat of combustion, you could ask them to do a calculation, and that would also cover a calculation requirement. So when we say based on the experiments, it doesn't have to be specifically what experiment did you do, but the question has to be in the context of the experiments. You could ask a question in general about fermentation or in general about heat of combustion, as long as it was linked somehow to a practical experience in the laboratory. One more thing I might do just before I finish, because I had a few questions about this, is with H3, H4 and H5, where would they go? Well, H3 is applications of chemistry, H4 is effects on the environment, and H5 is current research. So as a little tip, on this first page of the syllabus, applications of chemistry. We use chemistry to make things out of ethylene. Technically that's one potential application of ethylene. We make polyethylene using a whole range of chemical techniques. That's one application of chemistry, but probably the most important one is down here, applications, how chemistry or how chemicals are used is an example of a H3, applications of chemistry. Onto this page, the second page of the syllabus, this whole thing here, the fact that it's all about recent developments and progress is current research in chemistry. So that's a fantastic way to get a H5 question there, in current research in chemistry. Dehydration of ethanol, hydration of ethanol, this is a range of things. This is looking at current success of ethanol, so you could call that current research in ethanol. You could also talk about the reason we're going to ethanol is because of impacts on the environment. Fermenting, what conditions require fermentation and making alcohol? You could argue that's an application of chemistry as well, making fuels from chemicals. We haven't finished this page of the syllabus, but we're going to look at batteries eventually, and batteries are a great application of chemistry. We haven't looked at nuclear isotopes yet either, but we're going to look at how isotopes are used in industries. Once again, an application of chemistry. And we've already looked at this one here. This is all talking about the replacements of CFCs, what CFCs do to the atmosphere. This is all very much impacts of chemistry on society and the environment.